Thanks for the question. Here it is, composition of functions. Sulfur dioxide, SO2, is a greenhouse gas and a contributor to acid rain is emitted into the atmosphere by the burning of fossil fuels. A scientific study of the Kennesaw metro area suggests that the average daily level of sulfur dioxide concentration in the atmosphere can be modeled by the equation SO2 of P equals 1.32 P plus 560. It goes on to say that a function P of T equals 0.25 T squared plus 12, where T is the time measured in years from now. Okay, that's a long question. Looking at A, it says use arrows to show how the two functions are related. I'm not exactly sure what your teacher is asking you to do, but that just caught my attention because generally when you look at functions, you draw an arrow from the inputs to the outputs. Here is a function map. I don't know if you're familiar with those or not, but in the left circle, we've got the inputs, so generally the x values, and in the right circle I've got the outputs, generally the y values, or maybe if your function's f of x. So if you had a composition of functions, like say you had f of g of x, that means you're going to input x into g, and then you're going to take the output of g and use it as an input for f. So if I were to draw arrows like I have in my function map, I might draw an arrow from x to g of x, and then from g of x to f of g of x. So I'm drawing an arrow from the input to the output. So you might want to consider that when you look at your answer for A. But the one it looks like you're stuck on is C, where it says express the level of SO2 in the air as a function of time. So you have SO2 as a function of population, you have population as a function of time. So that's where you're going to actually go ahead and compose the functions. So I want to look at a simpler problem here. I've got two functions. F of x is x squared plus 1. G of x is 2x minus 1. It helps a lot if you understand function notation. So if I look at, like, say, f of 2, what does that mean? Well, it means replace all of the x's with 2's. So I could do 2 squared plus 1, and then I would know that f of 2 is 5. Sorry about that. I just got interrupted and I'm back. So we're looking at f of 2. Replace all the x's with 2's, and then we got f of 2 is 5. So same idea with composition. Instead of looking at f of 2, we might look at f of g of x. So we're going to replace all of the x's in f of x with g of x. So maybe I'll just do it like this. I'll put in g of x squared. So I replaced my x squared with g of x plus 1. So I've got the same function here and here, just instead of x, I have g of x. But really what I want to do is replace it with what g of x equals. G of x equals 2x minus 1. So really I want to put in there 2x minus 1 instead of the g of x. So there's my composition of functions right there. Maybe you want to multiply that out, and maybe that makes it more simplified, or maybe I can just leave it like that. But the basic idea is wherever I see an x in f of x, I'm going to put in the function g of x. So if we look at our functions here, they're ordered in a very specific way. SO2 is a function of p, and p is a function of time. So we want to make sure that we're looking at it in the right order. We want to make sure that we're looking at SO2 of p of t. So you're going to take your function for SO2, and wherever you see a p, instead of plugging in a value like you did for, I think this one, you're going to plug in this function. You're going to replace all those p's, there's just one, you're going to replace that p with this function right here. And then you will have SO2 as a function of time. Hope that helps. Good luck.